Rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. The book is Mathematics for IIT-JEE Main and Advanced by M.L. Khanna sir, and I am Subuh Nadeem presenting you the videos related to the chapter which we are discussing today. So the chapter here is right now Maxima and Minima. And first of all, let us see some basic concepts associated with Maxima and Minima. First of all, for a curve, if there is a local maxima at a point A, that means that f of A, this is f of A, is greater than f of A plus h and also greater than f of A minus h. So the point next to it and the point before it is less than f of A, where h is in the neighborhood. And similarly, if there is a point of minima and there is a point A, then f of A is less than f of A plus h, and also f of A is less than f of A minus h. So this is the definition of maxima and minima, and h is tending towards 0, that is, it is in the neighborhood here. So that means we call local maxima and local minima. And if you want to test local maxima and local minima, how do you test local maxima and local minima? So for the testing purpose, what we do, if we have the function differentiable, if f dash x is differentiable, then we find its derivative. And if it is equal to 0, at some point x is equal to a1, a2 like this, then these are the probable points of maxima or minima. Or f dash x is not defined, suppose, at some point, then also those points are the point of maxima or minima, maybe. So this is the necessary condition, not the sufficient condition. So this is the necessary condition here. Now if you want to find that whether it is a maxima or it is a minima, then how do you find it? What we will do, we have two tests. One is first derivative test. By the first derivative test, what we will do, that we will find the sign of the first derivative. So you can observe for a maxima, the derivative is actually changing sign from positive to negative as the acute angle, and here it is the obtuse angle. So the derivative dy by dx changing sign from positive to negative. What it means? It is a maxima. And if it is reverse, that is, if it is changing from negative to positive, then it is a minima. So this is the first derivative test. What is the second derivative test? When we do the second derivative test, what we do, that we find the second derivative of the function. And if the second derivative at a point a1 is greater than 0, then we say that a1 is point of minima. And if we find the second derivative at a1 as negative, then a1 is point of maxima. Now you may ask a question that if second derivative is equal to 0, then what we will say? Then we can't comment anything, we have to do further derivatives. So it is better to go for first derivative test if second derivative is 0, because it may be possible that it is neither maxima nor minima and it is a point of inflection also. So we don't know. What else we can talk about here is absolute maxima and absolute minima. So if it is a closed interval a comma b, then we have the absolute maxima and absolute minima concept. What it says, that out of all the point that we have in between a and b, we will find the local maxima and local minima. So first step, find f dash x equal to 0 or undefined at points wherever it is possible. So x is equal to a1, a2, so on. Now, second step is find f of a and f of b. So we have to now compare f of a, f of b, and f of x a1, f of a2, so on. Now whatever is the maximum out of all these is called the absolute maxima, and whatever is the minimum of all these is the absolute minima. There is a open interval concept also. If a question comes, we will see that also. Next we have few questions here. Now it says find the minimum value of a square by cos square x plus b square by sin square x. So this question can be done without differentiation also, but here I am using differentiation. So this fx is a square sec square x plus b square cosec square x. Now if I am differentiating it, f dash of x, I am getting 2a square sec x and sec x into tan x, like this. And this is 2b square cosec x into minus cosec x into cot x, like this. Now if we equate it to 0, what will happen? We'll get 2a square, and here it will be sin x upon cos cube x is equal to 2b square and cos x by sin cube x. Now we cancel 2 from both the sides, and also we can write b square by a square is equal to sin to the power 4x by cos to the power 4x, that is tan to the power 4x. So tan square x will be b by a. Because it is a square, it has to be positive, considering a and b are positive here, because a square and b square is there. So let us take a, b both as positive. Now this is tan square x. So at this moment, what is the minima or maxima it is? This we have to confirm. So how do we confirm? Let us apply the first derivative test here. So if we apply the first derivative test, what will happen? This is 2a square and this is sec square x, which can be written as 1 plus tan square x. So this will become tan x plus tan cube x. And another term is 2b square with a minus sign here. Cosec square x is 1 plus cot square x. So cot x plus cot cube x. Now we know that tan square x is equal to b by a. So this will become b by a plus 1 into tan x, like this. And here minus 2b square cot x, and 1 plus cot square x is 1 plus a by b. Like this we can write it. Now when we will simplify, so I am erasing the above part now, as we have calculated this portion. And now if we want to simplify it, in one step we will be able to simplify it if we calculate the most of the part mentally. So this is f of f dash of x. Now if we take double derivative here, so what it will give you? 2a square into b plus a by a into sec square x. That is the derivative of tan x. And what is the derivative of cot x? Minus cosec square x. So 2b square cosec square x into b plus a by b. Now as we know that tan sec square x and cosec square x both are positive, b by a, taking b and a as positive, this double derivative is positive. So this is a point of minima. So we can say that this is a point of minima. So if this is a point of minima, we can of course find the minimum value. So a square by cos square x. This is tan square x, which is perpendicular by base. So you can say that this is x, this is root over b, this is root over a, and this is root over a plus b. So cos square x will become base upon hypotenuse root a by root over a plus b. And then we have sin square x. So if we take sin square x, it will be root b by root over a plus b. So b square root b by root a plus b. So the final answer you will get is, let me write it here. You will get the final answer as equal to, here it will become a to the power 3 by 2. Here it will become b to the power 3 by 2. So root over a plus b into a to the power 3 by 2 plus b to the power 3 by 2. So root over a plus b into a to the power 3 by 2 plus b to the power 3 by 2. This is its minimum value which you are getting. Now let us come to the next question. Find maximum and minimum values of the following on the interval 0, 1. The function x to the power 25, 1 minus x to the power 75 takes its maximum value at the point. So you have to find here maximum value at the point in the interval 0, 1. So absolute maximum it is talking about. So if we talk about absolute maximum, first of all, let us differentiate it. This will give you 25x to the power 24 into 1 minus x to the power 75 plus 75 into 1 minus x to the power 74 into minus 1 into x to the power 25. So you will get as x to the power 24 into 1 minus x to the power 74, and you will get 25 into 1 minus x, and then we have minus 75x. So you will get x to the power 24 into 1 minus x to the power 74, and this will become 25 minus 100x. So this is what you are getting here. Now equate it to 0. So what you are getting, x is equal to 1 by 4 and 1 and 0. So 1 and 0 are of course the end points, the extreme points here. So if you want to find the value of the function at 0, it will be 0. Value of the function at 1, it will be again 0. And value of the function at 1 by 4. So that will give you 1 by 4 to the power 25. And this will become 3 by 4 to the power 75. So of course this is the maximum value. 0 and 0 are the minimum value. So you are getting maximum value at 1 by 4. Let us come to the next question now. The next question says the total area of a page is 150 square inches. The combined width of the margin at the top and bottom is 3 inches and the side is 2 inches. What must be the dimensions of the page in order that the area of the printed matter may be maximum? So let us suppose that dimension of the page is having length x and breadth y. Now it is said that 3 inch is being taken outside from the length here and here. So it is x minus 3 the printed area and y minus 2 here is the printed breadth. Now it is said the total area of the page, that is x into y, is equal to 150 square inches. Dimension of the page in order that the area of the printed matter may be maximum. So area of the printed matter is x minus 3 into y minus 2. So when you simplify it, xy is actually 150. So it will become 156 minus 3y minus 2x plus 6. Now here, as we know the relation between x and y is equal to 150 by x. So you can write, this was already included here 156. So we don't have to write plus 6 separately. So this will become 156 minus 3 into 150, that is 450 by x minus 2x. Now dA by dx will be 0 for the maximum area. So you can differentiate it, it will be 0 minus 450 upon x square with a minus sign and minus 2 is equal to 0. This is what we are getting. So x square is equal to 225 or x is equal to 15. And if x is equal to 15, then y will be equal to 10. So you can say that the margin is 15 into 10 for the maximum printed area on giving a margin of 2 inches width and 3 inches length. You can double differentiate this also, and you can verify that this will be negative on double derivative for the maximum area. But it is a common sense that here we are getting the maximum area. For minimum area, one of them would have been 0. Let us come to the next question. A window of fixed perimeter including the base of the arc is in the form of a rectangle surmounted by a semicircle. The semicircle portion is fitted with colored glass while the rectangle part is fixed with clear glass. The clear glass transmits 3 times as much light per square meter as the colored glass does. What is the ratio of the sides of the rectangle so that the window transmits the maximum area? So if we first draw the diagram of this, so it is a semicircular part and this is the rectangular area. Let us suppose the length of the rectangular area is 2r. So radius is r and the width is x of the rectangular area. Now the light which it is passing, the semicircular part, is 1/3 of the clear glass, and clear glass is the rectangle part. So this is passing 3c light and this is passing c light. Let us suppose ratio is 1:3. Now it is said, what is the ratio of the sides of the rectangle? That means r is to r is to x. What is this? So that the window transmits the maximum light. So the window transmits the maximum light. Window of fixed perimeter is there. So perimeter is basically, perimeter if you see here is equal to, as you can see, this is pi r plus 2r like this, and then we have 2r here also, and then x plus x 2x. So this is the perimeter, which is a constant value k. So you can say from here that x is equal to k minus pi plus 4r by 2. So k minus pi r minus 4r by 2, this is x. Now this is the value of x here, this width. And now we have to find the color which is passing through it, the light which is passing through it. So light which is passing through it is actually having this area which is half pi r square into c, the area here into the light which is getting transferred, and the light here is 2rx into c, 2rx into 3c, because it is 3 times. So next step what you can do, you can replace x by this value. So this, first let us take some constant outside, as you are getting r common and c common. So let us take r and c common. This will be pi r by 2 and this will be 6x. So it will be 3k minus 3 pi plus 4 r, like this. Now if we differentiate it with respect to r, the radius, because it is a function of r now, so I am differentiating it with respect to the radius. So let me erase this portion which we have already used in the calculation. So let us differentiate L. So dl by dr we are doing. So this will become pi into c r square by 2. So this will become pi into c 2r. So r it will become. And here 3k c into 1 minus 3 pi plus 4c into r square will be 2r, like this, and equate it to 0. So what you are getting the value here of r? So you are getting pi rc from here and minus 6 pi rc from here. So minus 3 pi rc. Not pi rc, minus 6 pi rc is actually 5 pi rc, minus 5 pi rc you are getting. And then plus 3 kc minus 12. Okay, so we have here pi plus 4, right? So let us write it correctly. The value of r, the value of r would become equal to 3 kc upon 3 pi plus 4 into c into 2, of course, and then pi c, like this. So c will of course get cancelled, as c was the light which is being transferred from the semicircular part, and 3c was the light transmitted by the rectangular part. So this will become like this. So you can write it as r is equal to 3k upon 3 pi into 2 is 6 pi plus pi, that is 7 pi plus 24. As the calculation is quite clear here. Okay, there is a small mistake here, that is, it is in minus. So this is in minus. So when you take it there, this will become plus and this will become minus. So this is actually not plus. Let me erase that part. This is minus. So this will become not 7 pi, it will become 5 pi plus 24. So it will become 3k by 5 pi plus 24 r. Now you have to find actually the ratio 2r by x. What is x? X is this one. So if you calculate x, you will get k minus pi plus 4 into 3k by 5 pi plus 24 upon 2. So this will become 5 pi k minus 3 pi k, which will be 2 pi k plus 24k minus 12k overall. And 2 will cancel. So it will be pi k, and then we have 24 minus 12 is 12, and then it will become half 6 plus 6k. So pi plus 6k you are getting finally. This is actually x. Now the ratio 2r by x will become 6k by 5 pi plus 24 upon pi plus 6k by 5 pi plus 24 here is there, of course, in the denominator. So you get pi plus 6k by 5 pi plus 24. Now this 5 pi plus 24 will cancel, k will cancel, and you are getting 6 by pi plus 6. So the final answer will be, when you write the final answer, I am writing it here after erasing this, you are getting the final answer as 6 by pi plus 6. 6 is to pi plus 6. This will be the final answer, students. So this is a lot of calculation involved here. So there are chances of calculation error, but you have to be quite cautious. This question says the function fx is equal to this one has a local minimum at x is equal to. So let us differentiate it. F dash x we get. So this will become x e to the power x minus 1, x minus 1, x minus 2 whole cube into x minus 3 to the power 5. And let us equate it to 0 for maxima or minima necessary condition. So x e to the power x minus 1, x minus 1, x minus 2 cube, x minus 3 to the power 5. So you are getting the critical points. Let us draw the sign scheme. 0 and e to the power x minus 1 will become 0 if x is equal to 0. So 0 is coming 2 times here. X is equal to 1, x is equal to 2 is there, and it is coming 3 times. And x equal to 3, it is coming 5 times. So if we do the sign scheme, it will be plus, minus and minus, because here it is even number of times. These are odd number of times. So if you draw the wavy curve, it would be something like this. Here, 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 sorry, and here. You don't have to go above here. You will move back. Now if you talk about the local minima. So for local minima, what is the condition? That first derivative, as you are taking the sign of the first derivative, it is changing angle from, the tangent is changing angle from obtuse to acute. So single derivative is negative to positive. So it is becoming negative to positive here at 1 and also at 3. So from negative to positive, it is at 1 and 3, positive to negative at 2. So this 2 is the point of maxima and 1 and 3 are the point of minima. So if you talk about the local minima, it will be at 1 and 3. Now there are two options, B and D. Which will you select? This is the question here. So as we are saying that we have minus to plus at 2 points, 1 and 3. So what you will say that 1 and 3 both are the correct answers. So this is the multi-correct question. Let us come to the next question here. A person being in a boat A miles from the nearest point of the beach wishes to reach as quickly as possible a point B miles from that point along the shore. So first let us draw the diagram till here. So what the diagram says, that a person is there and it is going to a shore which is A miles from the nearest point. This is the person and this is the shore nearest point. Wishes to reach as quickly as possible a point B miles from that point along the shore. This is R point, this is at a B distance, and he wants to reach here. The ratio of his rate of walking to his rate of rowing is sec alpha. So ratio of his rate of walking to his rate of rowing is sec alpha. Prove that he should land at a distance B minus A cot alpha from the place to be reached. So let us suppose this is the point where it has landed and this is at x distance which we have to find, and this is B minus x. Now you have to find that x is B minus A cot alpha for the minimum time. So this part is the rowing part. So this distance is root over A square plus B minus x whole square. So time taken for rowing will be distance of rowing, which is root over A square plus B minus x whole square, by speed of rowing, which is V. And time taken for walking will be x by speed of walking. Now it is given that the ratio of his rate of walking to his rate of rowing is sec alpha. So rate of walking is rate of rowing into sec alpha. So this is V sec alpha. So total time taken is equal to 1 by V into root over A square plus B minus x whole square plus x cos alpha. Now for minimum time, dt by dx should be equal to 0. So if we take dt by dx, this will become 2v root over a square plus b minus x whole square, and then we have 2b minus x with a minus sign like this, plus minus x sine, this is alpha, so it is still cos alpha because it is a constant, and the derivative of x is equal to 1, so I am writing it again in case you get confused. So this will become cos alpha as and then equate it to 0. So when you equate it to 0, what you get, let us erase this portion. So when you equate it to 0, you get the value of x from here, and what is that value of x? That should be equal to b minus a cot alpha. So let us calculate that part. So this 2 will get cancelled, v is also there here, so v will become 0 after multiplying with 0. So it will become b minus x is equal to root over a square plus b minus x whole square into cos alpha. Now let us square both the sides, so it will become b minus x whole square is equal to a square cos alpha plus b minus x whole square. It is also cos square alpha, this is also cos square alpha. So this is b minus x whole square, and 1 minus cos square alpha is sin square alpha, and this is equal to a square cos square alpha. From here you can write b minus x is equal to a cot alpha. So x is equal to b minus a cot alpha from here. So you can say x is equal to b minus a cot alpha. So this is the value which we had to prove here. Now let us come to the next question, students. A cone is circumscribed to a sphere of radius r. Show that the volume of the cone is minimum if its altitude is 4r and its semi-vertical angle is sine inverse 1 by 3. So it is something like this, that there is a cone and there is a sphere like this. Radius of the sphere is r. So this radius is r. So let us take altitude of the cone as h. So this is height h here. And its semi-vertical angle, we don't know, let us take at alpha. So we have to prove that alpha is equal to this and h is equal to 4r if we want volume of the cone to be minimum. So this is the angle alpha, this portion, only this portion, semi-vertical angle. So what we can suppose here, suppose that the radius of the base of the cone is capital R and the slant height is L. So what we can say, that this portion is h minus r, as this portion is r and this is the perpendicular. So we can say from here that first in this triangle A B C, then we will take APQ. Triangle ABC we will take. In triangle ABC we have sine alpha is equal to perpendicular upon hypotenuse like this. And then in triangle APQ, in triangle APQ we take tan alpha, which is perpendicular by base, which is r by h. Now if we find the relation between them, sine alpha and tan alpha, so we can say that sine alpha is actually r by h perpendicular by base, and this is perpendicular by hypotenuse. So we can say that we have tan square alpha is equal to sec square alpha minus 1, and this is 1 by cos square alpha. So this will be sine square alpha by 1 minus sine square alpha. Now sine square alpha will become r square by h minus r whole square, and here it will become h minus r whole square minus r square, and tan square alpha will be r square by h square, like this. Now we find a relation after simplifying this. This is r square by h square minus 2rh, like this, and 1h will get cancelled here. So we can say that h r square minus 2r r square is equal to r square h. Now let us see what we have to find. We will use it, but let us see what we have to find. You have to find the volume of the cone. And what is the volume of the cone? It is 1 by 3 pi r square h. So we will take volume of the cone as 1 by 3 pi r square h. So if it is 1 by 3 pi r square h, so r square h is actually from here written as 1 by 3 pi r square h, like this, plus 2r r square, like this. And then we have 1 by 3 pi r taken common, and we have rh plus 2r square, and this r square can be written as r square h upon h minus 2r. So we can write this r square as r square h upon h minus 2r, like this. This is how we can write it. Now if we erase this portion for now, and let us finally come to the derivative. So before finding the derivative, we can further simplify it if you want, or you can simply find the derivative here. This is RH. So this is RH square minus 2r square h plus 2r square h will cancel. This will become r square pi by 3 h minus 2r. And now we will take dv by dr dh is equal to 0, because h is the variable here, small h is the variable. Now when we take this as the variable here and we differentiate v with respect to h, so this is h here as I am again writing it. So we will get pi r square by 3 as the constant. This will be h minus 2r whole square, h minus 2r into 2h minus h square into derivative of h minus 2r will be 1 is equal to 0. So this is how you can write it. Now if you want to simplify it, you will get 2h square minus h square as h square. So you will get h square minus 4rh is equal to 0, which will give you h is equal to 4r. This is what we had to prove, h is equal to 4r. And now you can find the angle sine alpha. So what will be sine alpha? Sine alpha is equal to capital R by h. So capital R by 4r. And capital R we already obtained in terms of small r, that we can put and find its value. Now let us come to the next question, students. So the next question is, at x is equal to 5 pi by 6, 2 sine 3x plus 3 cos 3x is maximum, minimum, 0, none of these. We have to check. So the function fx is equal to 2 sine 3x plus 3 cos 3x, like this. Now if we have the derivative here, so derivative would be equal to 6 cos 3x plus 3 into minus 3 sine 3x. So that will be 6 cos 3x minus 9 sine 3x. Now for maximum of minimum, it should be equal to 0, which means tan 3x should be equal to 2 by 3, like this. So if you see here, at x is equal to 5 pi by 6, what happens? Tan of 3 into 5 pi by 6. That is actually tan of 3 into this 3 and 6 will cancel, and it will become 5 pi by 2, which is actually tan of pi by 2, which is undefined. So you are not getting it as 2 by 3. It is getting not defined. So clearly tan 3x is not 2 by 3 at x is equal to 5 pi by 6. So f dash x is not 0. Another case could be f dash x is undefined. But this function could not be undefined also, because cos 3x and sin 3x both are defined. So this has neither maxima nor minima at x is equal to 5 pi by 6. Now what about its value? So if we talk about its value, f of 5 pi by 6, it will be equal to 2 sine 3 into 5 pi by 6, that is 2 sine 5 pi by 2 plus 3 cos 5 pi by 2. This is what we are going to get. Now sine 5 pi by 2 will be 2 into 1 plus cos 5 pi by 2 will be 0. So you get 2. So it is still not 0. So we'll say none of these. So here in this, all the first three options are not correct. You have none of these as the correct option. So you will say that this is having option D as the correct option. That is all for today's lecture, students. Thank you.